In this section, we are going to talk about polynomial functions and their end behavior. So what is happening on either end of the graph? Which direction are your arrows going? That's what we are looking at. Now, we are going to describe end behavior in this class using limit notation. So this might be new compared to how you learned to write it last year. So even though this is a review topic, we're going to be introducing some new notation. So the end behavior of a function describes how a function behaves as it moves infinitely to the right and infinitely to the left. Now remember, when we read a graph, we're talking about the x values as we move from left to right. So as my x's get bigger and bigger and bigger, I'm moving to the right. And as my x's get smaller and smaller and smaller, I'm moving to the left. So what we are looking for is, what are the arrows doing? Is it pointing up? Is it pointing down? So the end behavior is what happens to the values of f of x, your y values, as your x either increases or decreases without bound. Whenever we talk about something increasing or decreasing without bound, we are always going towards either negative infinity if we're decreasing without bound, or positive infinity if we are increasing without bound. That phrasing is something you want to be really prepared for and comfortable with for the AP exam. The idea of increase without bound, decrease without bound. You'll see that verbiage quite a lot on the AP exam. Okay, so here is how we can use this limit notation to describe the end behavior. The symbol for limit is always going to be this LIM, and then underneath it is what x value you are approaching. So the way I would read this first one for the left end behavior out loud is to say the limit as x approaches negative infinity of f of x, okay? Now, it is not a fraction. Some mistakes that I see commonly with incorrect notation is people like saying limit divided by. That is not. It is all one thing hooked together. It has to have the x with an arrow and then a value or positive infinity or negative infinity that it is approaching. And if we think kind of in terms of those little racetracks that we learned to write on when we were little kids, just to understand how this notation looks, the limit is kind of up above and the x approaches negative infinity as on the bottom there. And then the f of x is normal size. You always have to have a function inside it, okay? Limit is an operation the same way square root is an operation or log is an operation. You can't just write ln. That doesn't do anything until you do it to a value or to a function. So anytime you write a limit, it's got to have three parts. It's got to have the LIM. It has to have x approaches a number, and then it has to have something that goes inside of it, okay? So you got to have all three parts when you write it. So what the limit as x approaches negative infinity of f of x means is not what is f of x equal, but what is f of x approaching? What is it going towards? That's what limit is talking about. So as the x values decrease without bound, that's going to be negative infinity. The y values of f of x are doing what? Are they increasing without bound or are they decreasing without bound? Okay, so the left end behavior is always going to be associated with negative infinity, and the right end behavior is always going to be associated with positive infinity. So let's talk about this verbally, and let's talk about with limit statements. So here is a polynomial function. My end behavior is up on the left and down on the right, okay? So verbally, I would say as x decreases without bound, I'm abbreviating here, but remember, when you take your AP exam, you should not ever abbreviate anything. So as x decreases without bound, f of x, since my left arrow is going up, it increases without bound. Again, that phrasing without bound is really important. So now let's look at the right. That arrow is going down while my x's are getting bigger because I'm on the right side. So I would write this in a very similar way. As x increases without bound, that means as I move to the right, f of x decreases without bound, which means my arrow is pointing down. So here's how we would write this using limit statements. Anytime we are doing the left-hand side, we're going to start with the limit as x approaches negative infinity we'll call this function f of x. It wasn't given a name, but we'll just call it f of x. So we'll label it there. So the limit as x approaches negative infinity of f of x equals, since f of x is increasing without bound, we are going towards positive infinity. Now for the right limit statement, we would say the limit as x approaches positive infinity of f of x, and that is going to equal, as I move to the right, f of x decreases without bound, so we go towards negative infinity, okay? Alrighty, so let's look at another one. I would encourage you to first identify what is happening. I have up on this side and up on this side. X's are decreasing on this side. X's are increasing on this side. So pause your video, see if you can write these answers out, and then come back and check. I'll be back in 3 seconds with the correct answers. All right, here's what we should have. As I move to the left, my arrow is going up. So as x decreases without bound, f of x increases without bound. So the fact that x is decreasing means we're going to the left, and the fact that f of x increases is because the arrow is up. On the right, as x increases without bound, f of x also increases without bound. So our left limit statement is the limit as x approaches negative infinity of f of x equals positive infinity because it's going to the left. And the right side is the limit as x approaches positive infinity of f of x equals also positive infinity because it is going up, okay? Make sure you check what you just wrote down. Make sure you have a function. If you called it something else this time, that's fine. But make sure there is a function inside your limit to be fully correct. Okay. Example 2 says, sketch a polynomial with the following end behaviors. So this is just practice reading what these limit statements mean. So the first one says the limit as x approaches negative infinity of f of x. Because that is the negative infinity side, this means this is what our left side does. And since it goes to negative infinity, our left arrow should be pointing down. The limit as x approaches positive infinity is going to be our right side. And since it approaches negative infinity, the arrow should also be going down. So you can draw whatever you want, but it has to end so that our arrows are going down on each side. You could do a parabola. You could do something that goes up and down a whole bunch of times. It doesn't matter. The middle can be anything as long as you have arrows on both sides going down. So pause your video and see if you can sketch a graph with the properties for part B. All right, so we need a left arrow down and a right arrow up. Now, just something that I want to show you. Do not automatically assume that the first one is the left. You always need to check because there's not a specified order that they need to be in. So the first one could be the positive infinity side, and that would mean it's on the right. So again, for this one, you need an arrow that's going down on this side and an arrow that's going up on this side. Whatever you want to do in the middle is up to you as long as the arrows are correct. Okay? All right. Now, we can tell what the polynomial end behavior is going to be just by looking at the equation. So the right side is always going to go up if the leading coefficient is positive. It is going to go down if the leading coefficient is negative. And that's true for everything on the right side. The fact that it's the right side is really important there, okay? So the leading coefficient, positive or negative, tells us whether the end of the graph, the right side of the graph, is up or down. The left side depends on the degree. So it will go in, whoops, that's a highlighter. It will go in the same direction as the right if the degree is even. So if it's positive on the right and my degree is even, then it will also be positive on the left. I think I said right a second ago, but this is the rule for the left side. So it will go in the opposite direction as the right side if the degree is odd. All right. So using those rules, if we look at example 3, we're not going to do every single one of these, but so I just need to look at the degree and the leading coefficient. So it says determine the end behavior, use arrows to describe the end behavior. So we just need arrows. We don't need to write a limit for this one. So if I look here, this has a leading coefficient that is positive. That means my right side goes up. I have a degree that is odd, so that means my left side does the opposite of the right. Okay. On B, my leading coefficient, 1/2, is positive, so that means my right side goes up. My degree is even, so that means my left side does the same. It also goes up, okay? Pause your video and take a moment to try C, D, E, and F. Make sure that you find the leading term, even if it's out of order. So that's the highest powered term. And I'll come back in 3 seconds with your answers. All right, here is what we get. Now, what I want to make sure that you pay attention to is how on D and E, the leading term is not in the front position. Also, make sure you take the sign with it. So 3 minus x to the 5th makes my leading coefficient negative, and my degree is odd. So negative coefficient, right side is down. Degree odd means left side is opposite. So we get up, down. And then on F, we've seen this when we were looking at polynomials in section 1.5. I need to take all of the x terms. So I've got a 2x. This is a first power. This is a first power. So I have an x to the first and a negative x to the first. If I multiply those all together, I get negative 2x cubed, and that's how I decide, okay? Now, example 4, they want us to write limit statements this time, but I will still start with arrows because it helps me set up my limits. So for A, I have a negative leading coefficient, which means my right arrow goes up, and an even degree, which means my left arrow matches. So I need up, up. I'm going to set this up as my left arrow, the limit as x approaches negative infinity of f of x equals, since the left arrow is up, it is positive infinity. And then the right side would be the limit as x approaches infinity of f of x equals also infinity, okay? Whatever the name is, that's what we're going to put in here. So notice on B, it's g of x this time. So we're going to write g of x, not f of x. Again, pause your video, draw arrows, and write limits for B. I'll be right back. Okay, so our left limit, the limit as x approaches negative infinity of g of x, should be negative infinity because the left side is going down. And our right side, limit as x approaches positive infinity of g of x, equals positive infinity because of the up arrow. Now, you can use your graphing calculator to graph A, B, and C. These are not necessarily all polynomials. The first one is so you could use the test we just talked about with your leading coefficient and your degree. But B and C are not polynomials. So put those in your graphing calculator, look at what the arrows do, and write your limit statements. You can go ahead and give those a try and look up the answers on your PDF file on Canvas to keep this video short. So that is it on end behavior, and you have a worksheet to work on that goes along with this, and I'll see you soon.